laws. So we're going to start with identity laws. So the first one that you need to understand under the identity laws is that whenever you've got A union empty set is equal to A. This is what you need to know and understand. Now, how can you prove this? You need to know how to prove this. You need to know how to prove this. So proof. How can we prove that? You know that you've got A union empty set. A union empty set is equal to what? Use set builder notation. So be using set builder notation to prove all these. This means that X such that X is a member of A, which is here. There is union. Union means O. X is a member. Is a member of what? Empty set. You do this, then you cross. This is what you are going to be doing. From here now, you know that since you know that an empty set is a set which has no element in it. So this is just the same as A union empty set is equal to X such that X is a member of what? Is a member of A. So X is just a member of what? A member of A. If X is a member of A, meaning it's just equal to what? Is just equal to A. So we've proven the first one. So this is how you need to prove. You don't just need to know the laws, you also need to prove them. So this is how you get to prove the first one. Under identity laws, we also have this next one. So here, therefore, I've proven that A union empty set is equal to A, and the procedure is above. Here, this is how you get to prove them. So we move to the first one, the second one. Under the second one, let's say you've got A intersection universal set is equal to what? Is equal to A. So A intersection universal set is equal to A. How can you prove this? So how can you prove this one? I'm going to teach you how you can prove this one. The way we get to prove this one is where you say, you're going to say that A intersection universal set is equal to, so you know that X such that X is a member of A. Intersection means and. You say and X is a member of what? The universal set. This is what you are going to do. So from here you know that if X is a member of A and X is a member of the universal set, every element which is in the set A is also in the universal set. So meaning X is just in set what? Set A. So this means just the same as you're talking about one set here, which is just equal to, so it's just X such that X is a member of A, like this, which is just the same as what? Set A. We're just talking about the same set, which is set A. So this is the first law that you need to understand. Hope you've seen how I'm proving this. This is the same way in which you also need to prove this. You understand them from this angle. So these are very important. Make sure you get them, you understand them. So which means therefore A intersection U is equal to, U is the universal set, is equal to A. So we've proven this one. You know how it has come about. So this is the first one. Let us move to the second one. Let us move to the second one. So we move to the second one. Let's move to the second one. We move to the second one. Let's move to the second one. So I'm going to lab these like this. We move to the second one. Let's move to the second one. So the second one is called Idempotent. So it is called the Idempotent. Idempotent, like this. Idempotent laws, like this. This is the second one. So this one is the simplest of all. You are going to understand it. It's just the simplest of all, this one. So how do you go about this one? This one, you know that the first one, so I'll say A. You know that A union A is equal to A. Just like that. A union A is equal to A. Have you seen the way I've done? So how can you prove this now? How can you prove? I've told you that you also need to know how to prove this. So this is just the same as what? It's just the same as A union A is equal to what? We are going to say that X such that X is a member of A, or since there is union here, you say or X is a member of what? Just a member of A. So have you seen here we've got set A, even there we've got set A. So we are just talking about the same set here. This is just the same as what? It's just the same as X such that X is a member of set A. Like this. Which is just equal to what? Just equal to A. We're just talking about the same set. So this is how you need to prove this one. This is the procedures you need to get. This is how we prove this one. Where you say that therefore A union A is equal to A. You've proven this. We've proven this one. So each law has got two properties that are there. So now we move to the next one. Let's move to the next one. We move to the next one, which is B. The B part. So the B part is A intersection A is equal to what? Is equal to A. So even as we are discussing about this, one thing you need to know is that we are going to apply this in an exam where you are going to see how questions get to come. So make sure you understand this correctly. Make sure you understand this very well. So this A intersection A is equal to A. What does this mean? This means that A intersection A is equal to what? We are using set builder notation. So we get to use set builder notation. Where you say X such that X is a member of A. There is intersection there. So we say and X is a member of A. You do this. Have you seen? So the same way I'm doing them, that's how you also need to do them. Where you say, this is the same as X such that there is A here, there is also A here. So just talking about X is a member of what? Is a member of A. Like this. Imagine one set intersecting with itself. What are you really talking about? You're talking about the same set. So which is just equal to what? Equal to A. Have you seen? We've proven this. So what we get to do now, you just say, therefore, A intersection A is equal to A. So these, you need to know them. Certain questions will be told to simplify, where you are going to apply all these laws that we are doing here. You are going to apply them. So let's make sure that we know these, we understand them clearly. These ones are very simple to